Hi, Sudeep.
Hi. Sorry, I think I joined the lag end of the previous call.
Yeah, no worries. I'll just quickly introduce you and then you can take over. You already
Sure.
have time. So, for this talk, we have with us Sudeep George, the VP Engineering at iMerit, who will talk to us about solving edge case with greater precision and efficiency. Sudeep has overall experience of more than 18 years specializing in imaging sensors and computer vision. He's an engineer from Kuwempu University and has also worked for companies like Infosys and Samsung during his career. So let's not delay it further. Let's welcome him to MLDS 2022. Hi, Sudeep. The screen is all yours. Please take over.
Thank you very much for your welcome. Really excited to be part of this developer summit. Let me quickly bring up my presentation. Is my screen visible?
Yes, yes.
All right. So once again, thank you for setting up this session. The topic that I'm going to be discussing about is solving edge cases with improved efficiency and greater precision. Before I get started, I'd like to quickly give you a background about iMerit. We started off in 2012. We are headquartered in the US. We started with a social impact mission where we wanted to train individuals who were below economic levels to come up by the virtue of providing them with technical training. And along this journey, by being essentially at the right place at the right time, we've been able to ensure that a lot of the work that we do is at the cusp of cutting edge AI getting into production. For example, we work with the top four self-driving car companies across the world. We help them in launching their products. And this is just one example of one of the domains that we work in. Apart from automotive systems, we also work in medical imaging, conversational AI, NLP, etc. These are some stats about the company. The bottom line being that we have a large talent pool of experts who've been working in the AI space for a very long time, and we've got a lot of work under our belt. And this is what enables us to bring our experience and our processes to help companies launch their products, specifically AI-enabled products, into the market faster. These are some of the topics that I would like to cover during this discussion. I'd like to give an overview of edge cases because edge cases have different connotations depending on which perspective we are looking or even working on from an AI pipeline. I'll also like to showcase the importance of the human expert in the loop. There's still a very significant role that the experts play in developing AI systems. And based on our experiences working with a lot of companies releasing their products into the market, I'll also like to list out some of the challenges and then get into some of the tools and processes that we have developed to help these companies release their products. And then we can have a final Q&A session. I'd like to start off with a very simple example. Imagine an AV system being trained to recognize stop signs. It is trained with real-world images like this battered-looking stop sign. Not all images are this simple. They could also be complicated images like these rules for parking zone permits. But AI systems today are well trained and pretty capable of parsing these images, understanding the rules, and setting up the intelligence accordingly. So the model is trained very well. It is tested in-house. It is then deployed. But the moment it's deployed, it runs into real-world scenarios where the stop signs are covered with snow. They may be covered with graffiti or may be blocked by trees, branches, other vehicles. The list goes on. This is just one example of the complexities of releasing products into the market. You may train as much as you can, but there's always going to be one such situation, one such scenario that defeats your AI system. And solving that problem is what drives many of these companies today as they start launching their products. For a long time, people have been developing models to improve the performance, but now the emphasis is on getting all sorts of data uh, and train the systems with these various data modalities to help the systems understand and parse the real world better. So why are we at this problem? We've been working on AI for a long time. Why isn't this solved yet? At the heart of it is what is called as the problem of the long tail, or the 80-20 problem. In simple words, 80% of the cases are very easily imagined, very easily trained, and very easily tested. So the system, the models are robust for those instances. And when I talk about very easy, I'm extrapolating quite a lot, but essentially it is a simpler problem to train for the vast majority of these cases. But once these systems start getting deployed into the real world is when they start getting into the domain of edge cases, where there are very few training instances that replicate that particular scenario. And because there are very few training instances, it is also extremely hard to test the model in the real world to understand how it performs for those edge cases. And as companies mature and they spend more time on developing their products for the AI market, the long tail starts to extend, and essentially the area under the lower end of the tail starts to extend such that the area becomes equal or more than the area under the head classes. In other words, you never run out of edge cases and you're always encountering issues, and that delays or reduces the efficacy of your products as they are released into the market. So why are we at this problem? At the heart of it, there are a lot of reasons, but we can go back to one of the root causes, and that is the data. On the left, you can see an example of a data set that is used for training face detection models. Now, as a data set, it has a very good spread of data across various classes, etc. But as you start going into those unique situations, like for example, people with caps covering their face or other facial expressions, you get very few examples and very few instances of those scenarios. And hence, your training fails. And once your training starts to suffer, then the rest of the AI development process also feels the impact. So this was a theory. This is an example of a real world problem that was raised by a owner of a self-driving vehicle. So this particular individual complained that their vehicle would always stop as they crossed this particular building. So upon a lot of analysis, it was found that many of the logos on this building are very similar in shape, color to that of stop signs. Now we can dismiss this as a one-off problem, but there are 95 such locations just in 5 states across the US. So at 95 different locations, there is an edge case that can cause unforeseen consequences. And that is why this is a painful problem for most companies to solve. I again emphasize on the AV domain, where in this particular example, an AV system is tasked with distinguishing between a real person and the reflection of their image on a glass pane. This is a very common urban scenario, but for an AV system to distinguish this very accurately, they have to make sure that they make use of other cues. And these other cues can only be provided by humans who understand innately how to pass this particular scene, but have to codify it for an AI system. This is an example of a project that we conducted for a customer, where the customer wanted to train their model to recognize weather conditions. So they collected data from their forward-looking cameras, which were mounted on vehicles. And on the basis of whether there was snow, whether there were puddles of water, droplets of water, etc., the model was being trained to recognize the weather conditions. But what happened in reality is, as soon as these models were released into the production mode, turned out that the models were performing very badly. And that is when, along with experts at iMerit, these customers sat down and figured out how do we actually go back and train the models to understand all the cues that are present in the data, and use those attributes to train our models better. In this particular example, the shadows cast by the vehicles in front of these cameras were also being marked to help the AV system understand that if there are shadows, then the probability of a clear sky is much higher than that of a cloudy sky. This is just one such example. And obviously, this is not the only solution to this problem, but it's this combination of cues that help resolve most of these edge cases. This is an example of where human domain expertise is very much required to steer an AI system into producing the kind of quality output it should. Here, this is an example from medical imaging, where the AI system is trying to distinguish between tumor cells and stromal cells. Our annotators who are now trained to, and they come, and many of them come with medical background, actually sit down and go through each of these images to look at it minutely and figure out which are the cells of concern and label them appropriately. As you can see, these are very small objects, and the nuances or the cues to distinguish between a tumor cell or a stromal cell are very minute. So just bringing this back all together, why is handling edge case important? You may have come across a car like this in front of you as you drive around. It's very easy, and you probably wouldn't even spend a thought on knowing that this is harmless and can be safely ignored. But an AI system has to pass this entire image, understand that the objects are of no consequence and can be safely ignored. All of this happening within a fraction of a second. And that is why handling edge cases becomes extremely important, because the room for error is vast and also very expensive. I'd like to just get into some of the definitions for edge cases, because as I mentioned in the beginning, depending on which part of the AI pipeline you're working on, an edge case could have different connotations. In the data collection phase, it could refer to whether you're collecting data to represent all scenarios. A simple example, are you collecting data for day conditions, night conditions, cloudy or clear sky conditions? In the data labeling phase, it is about whether you're interpreting the data correctly to classify and structure the raw data. Again, it is very easy to interpret a data in multiple ways, and doing that accurately is of huge significance in order to ensure that the models meet the required performance metrics. In model training, an edge case could be referring to the fact as to whether your models have been trained to handle all the classes properly, if your validation data, your training data sets are set up properly. Are you using the right metrics to calculate the performance of your models? Are you using an IOU or a DICE score? All of these individual factors impact the performance, and each of them could make or break a system. And in the real world, it is all about how does the AI system perform? Does it handle most of the scenarios? What are the implications if it doesn't handle it? And how well does it handle new or rare scenarios? I'd like to now talk about some of the challenges that we have seen companies encounter that are being deployed. And I'd like to again emphasize on the fact that these are being deployed. So and for many of our customers, the amount of data that they collect to train these systems is vast. And in order to release their products, they have to go to multiple challenges, both from a technical as well as a legal, commercial perspective. So each of these challenges kind of gets amplified across the entire life cycle. First and foremost are guidelines. Knowing that you need to collect data in a certain way, you need to structure data in a certain way is something that needs to be set up at the beginning. But in order to do that, you should have the foresight, the expertise to do that. And this experience can only come over time. One of the biggest challenges that most companies face as they enter the AI space is to reduce this time gap to make sure that they are able to quickly get the expertise and provide the necessary guidelines to build their products. The second major challenge is oversight. There's a human involved in this loop, and where humans are involved, there is a possibility for errors to creep in. So handling these human-driven errors is another challenge that many of the companies face. It could be you trained your data on the wrong data set, you used the wrong model, you tested on the wrong set of test cases. So all the paradigms of ML ops come into this particular area. The third reason is data that is very hard to collect. This is predominantly an AV problem because it's hard to construct a lot of these scenarios. But the same thing could apply, the same challenge could apply to other domains as well. In AV, while you may have a guideline which says that you have to get data which captures how the camera is performing at night time under rainy conditions in some with mud splattered on on the lens. That may be a guideline, but setting up this entire scenario and collecting data is a very expensive proposition. And the fourth is the never imagined case. You never really thought that this could be an issue. It could, and with hindsight, it is always something that should have been thought of, but in many cases, you just don't have that as part of your radar as you're developing your system. To give you an example, a real world example, a couple of years back, Tesla T-boned into a truck, and it was a fatal accident. In this particular instance, it so happened that the sun was at a certain angle, so the glare of the sun was affecting the camera. The truck was white in color. A combination of these factors confused the AI system, and the appropriate precautions weren't taken. So these are some of the real world implications of these never imagined or hard to foresee situations. What are the main reasons that kind of make the edge case and also developing AI systems that can perform very well in real world very important in today's global scenario? One, and the most important, is the liability. For most of these AI systems, as they get released into the market, you are liable for how your system performs. So making sure that it can meet most of the performance criteria is of paramount importance. And some of this paramount performance criteria could be aspects like accuracy. Are you able to clearly classify that a particular sign is a stop sign and you're at 98% accuracy about it? That is very important. Reliability. Can you classify a stop sign under all possible conditions? Whether it's day and night, whether there is a glare of the car behind you on that particular stop sign, any of those factors could affect the performance. Adaptability. A lot of face detection models were trained to perform really well. With COVID, people started wearing masks. Can your AI model adapt to that quickly? How quickly can it adapt to those changed circumstances? And then complexity. I'll talk about it in the upcoming slide, but complexity is primarily the fact that most of the AI systems that get released into the real world are highly complex because they're solving complex problems. And so it is not one AI model, it is a multitude of AI models that come together to solve a particular problem. In this example, I'm trying to highlight how individual models can be designed to handle one part of the problem statement. So whether it's object detection or trajectory generation, you could have a model specific to each of these tasks. Each of these models would encounter edge cases, but they could be resolved. And the implications for for failures here are limited to that particular part of the problem statement. This is all great. It works perfectly fine in labs and in controlled test environments. But in reality, an AV system that is deployed consists of a multitude of such AI models being brought together to solve the actual problem. These are some of the AI models that are used to solve the problem of perception in autonomous vehicles. As you can see, an error in any one of these particular models can get amplified. It can skew the other models which are set up as part of the pipeline and affect the overall performance. So handling these complexities is why edge cases are slowly becoming the main driver to determining whether your model can actually perform in the real world or not. In these set of slides, I'd like to talk about some of the experiences that we have distilled into a set of features which are both process features as well as tool features. And we've developed solutions to kind of make sure that we help our customers in closing the gap in resolving edge cases and also releasing their products faster into the market. I'll first start with some of the pain points that typically happen as you resolve edge cases. So one, there is tribal knowledge. A lot of the knowledge is kept within a certain team, within a certain domain. But most of these problems are cross-domain. You may, for example, in today's AV space, people use visual data, that is camera, LiDAR, or even radar, but they also combine that with other modalities like audio. They may choose to add other data points to kind of build up a model and also build the data points to take a particular decision. So understanding each and every aspect of of these domains becomes very important. And the next biggest issue is the time that it takes to bring together all these various experts onto a common platform to discuss a particular edge case that has been raised. These edge cases could be, very simple, could be handled in a matter of hours if it is a guideline issue. But in certain cases, if it is a new or unseen scenario, then it could take days or in certain case weeks to solve many of these issues. So time becomes an overriding factor because in today's global world, people are spread across. Getting them all to come together to understand and discuss the problem itself becomes a challenge. And it becomes a challenge because independent of the kind of the size of the company, a lot of these processes are not really well refined. They're quite ad hoc. A lot of the communication that takes place as part of these discussions gets lost, and kind of keeping a trace of what was the decision taken and why was it taken becomes a challenge. And it becomes a challenge because traceability is very important when you also have a legal obligation to determine why you've taken a certain decision. So making sure that you're able to trace the entire path and also to make sure that you can do an RCA at some later point is very important. And all of these individual problems may sound simple, but when AV systems or forget AV, AI in general are being trained on hundreds of millions of data points, scalability becomes the biggest concern. It is extremely hard to scale these systems unless there is a well-determined and a well-thought-out process. And that is where iMerit's edge case solution comes into picture. So we've been at this problem for a long time. We built our own in-house pool of experts who've been predominantly just focusing on resolving edge cases. We work with a multitude of customers across different domains. So distilling all of those lessons learned, and there have been some hard lessons learned, we've kind of put together a platform, a framework, where a lot of the conversations, a lot of the processes are very well constructed so that there is one platform where everything is automated so that there's traceability, time delays are reduced, all the discussions, the analysis are captured. But these are all specifically process related improvements. The biggest improvement is the knowledge bank. because most of these problems that are solved will reoccur in a different scenario with a different nuance. So having a knowledge bank that can actually capture a lot of these data points and use that knowledge bank to kind of drive further future decisions is very important. Another aspect that iMerit focuses on is to use this knowledge bank to train our own pool of data annotators. For example, a lot of the edge cases get revised in the form of automated tests. So you have gold standard data that is created, and then you automate a lot of these scenarios, and annotators train against these scenarios. So as the problems are dealt with, you also have the knowledge being spread across a larger pool of people so that you can improve the speed at which future issues can be resolved. This is the evolution of how edge cases are going to be handled. For a long time, edge cases were all about, okay, let's solve this particular problem and move on to the next uh, issue. But there is also a growing need to kind of leverage the lessons learned, the information, to kind of build, a model, for lack of a better term, a model of the scenario and apply that model across different use cases. So in this particular solution, what we do is we flag all edge cases. It could be edge cases that are reported by the annotation teams. There are flag edge cases that could be reported by the people who are working as part of the MLOps pipeline, or it could be edge cases coming live from the field as part of a continuous training feedback loop. All these edge cases are flagged, captured, and then we run our own proprietary software which extracts the metadata. So what are the attributes of each of these edge cases? And once we collect the metadata, we of course have to sanitize it, because we work with a lot of customers and we make sure that the data is protected. And once this data is sanitized, we then start figuring out what are the scenarios, what are the possible combination of data points that can be created to reproduce a scenario or to create various iterations of the same scenario. Once we are able to mine those scenarios, we then create simulations. And with those simulations, we then figure out how do we want to augment the data. It could be with the help of synthetic data. In certain cases, this goes as feedback to the data collection teams who go and they start capturing data from the field to handle that particular scenario. All said and done, a combination of real world data and synthetic data is then used to validate the model. And once the model is validated, it then gets released back into production. Now, all of this does happen, but it happens today in very isolated and not very well connected methods. So putting all of this together, bringing experts who can handle each of these various uh, areas and make sure that the lessons learned are being utilized for the next set of problems that come in. That is, I think, the path and the evolution for handling edge cases. As part of providing these solutions, we also provide a lot of ancillary help. So one is we have experts in the loop. We have people who have been working with self-driving car companies. They understand the nuances of collecting AV data, handling AV data, interpreting AV data. So you have those set of experts. You also have data set management tools that are developed. You would want to search your annotated data. You would really like to know, in as an edge case is being worked upon, what is the evolution of that particular classification from frame 1 to frame 10, for example. So having tools that help you search annotated data is also important. That is part of an offering. Then providing data so that synthetic models can be created and simulations can be created are all derivatives of the edge case solution framework that we have. And of course, All of this is then used to classify the models, to check their performance, and to make sure that this process keeps repeating itself as part of the continuous training feedback loop. So to summarize, edge cases are part of the AI landscape. You have to deal with it. There are lessons learned, there are experiences that have now been distilled to help you navigate through this maze of edge cases in a much more efficient manner. It is very important to use the right tools, because uh, you could do everything ground up, but having a framework that brings together the various tools, the various processes, helps you reduce the time that you spend in training and developing models and releasing them into the market. So with this, I come to an end of my presentation. Happy to take any questions.
Okay, thank you, Sudeep, for such an interesting session. We have one question on the chat box. Could you please elaborate on annotation and its role in detecting edge cases?
So annotation and its role. So if you look at annotation, typically is performed on the basis of guidelines. Now, the question is, what kind of guidelines can you provide to make sure that annotation is being done as efficiently as possible? For example, if you go back to the scenario where I pointed out about the shadows being used to provide cues to the model, you would want to make sure that all of that comes as part of your guidelines for annotations. So that is where the experts come into play, and you would then, with the help of these experts, determine what are the best set of cues, best set of attributes that you want for a particular data set to be captured.
Okay, I hope that answers the question. We have one more question on the chat box by Anand Jha. He's asking, does it make sense to not go after few edge cases, which is kind of overkill, and make systems fail safe, or just preempt some human actions if face never seen cases? A trade-off between cost and efficiency.
Sure, you could do that, but it really is a very domain-specific question. You could, for example, do that, let's say, in document AI, where the implications may not be very costly. But if you were to do that in the autonomous mobility space, for example, if the vehicle suddenly says that, hey, I can't handle this, or I'm going to go into fail-safe mode, and just stops in the middle of the road, it's a problem. So it is possible, it is a feasible solution. And in many cases, people do choose to do that, but it's very domain specific.
Correct. So how to discover edge cases as per the process flow before retrieving? And Anvesh is asking.
Yeah, so simple answer is you need to really have the experience, and you need to work with experts, right? I mean, there's no shortcuts here. If you look at the trajectory of all the AV companies, and I'm giving AV as an example, but please remember that everything that I've said applies equally well for every other domain in the AI space. But if you take the trajectory of AV companies, all of them follow the similar trajectory in terms of the time they're taking to actually release their products. And the reason for that is that there are no real shortcuts here. Of course, the lessons learned from others can be applied, but you would not be privy to a lot of these lessons learned. So getting experts who really understand the domain is very important, and getting experts who have, for example, classified data quite in quite detail for each of those domains is very important to fast forward this whole process.
Okay, I hope that answers Anvesh's questions. Sachin is asking, how would you flag and annotate one-off anomaly, say from a CCTV camera, streaming 30 FPS where anomaly persists only for a few seconds?
So that's where your continuous training feedback loop comes into play. You need to have a feedback loop that can immediately figure out, hey, is this the performance that was needed, and this is what actually happened. Of course, in the case of a CCTV camera, where perhaps the oversight may be limited, it could be a harder problem. But essentially, in order for you to understand what to do with the edge case, you will have to have a continuous training feedback loop in play.
Okay. Sudeep, we have one more question on the Q&A tab. This is one is asked by Arun. He is saying, great session. Could you please let me know if there are leading successful algorithms and ML techniques that are successful in edge cases?
Not really, because an edge case is basically a scenario that you haven't really trained for. So to give you a simple example, as a human, you may look at a particular scenario and think, is this safe, right? But an AD or an AI system would look at a scenario and say, hey, have I been trained to recognize this scenario? So that there lies the difference, right? So an AI system is only as good as the data it is trained on. I would encourage you to look at data as a very important aspect of your AI learning process. For a long time, it has been about models and improving model performance. But in today's paradigm, the role of data is equally or even more important. And I would recommend that you look at Andronic's presentations and talks to understand some of the implications of ignoring data as part of your ML training process.
Okay, I think those were the questions for now. But thank you so much, Sudeep, for such an interesting session on edge cases. And I hope this gives us a lot of understanding for our audience.
Sure. Thank you very much. Been really great to be part of this session. Thank you.
Thank you, Sudeep. Sudeep would also be available on the lounge section. So please, if there is any more questions that we could not take up at this session, please reach out to him and he would be happy to answer those.
Thanks again. Have a good day.
Bye. You too. You too.